Hey guys, Mr. Backerberg here. In this video, we're going to look at solving absolute value equations. So when we're talking about absolute value really means the distance a number is away from zero. Now when we write out an absolute value is shown with two vertical bars. So for example, if we wanted to look at the absolute value of some unknown number x being 7, what we're really talking about here is we're looking for unknown values, unknown numbers that are 7 spaces away from 0. And there's two answers here because there's two numbers that are 7 spaces away from 0. If we think about a number line and we put 0 in the middle, if we were to go 7 spaces to the right, that would land us at the number 7. So one answer to this equation is x equals 7. Because 7 is 7 spaces away from 0. Now, if we were to go the other direction, well, left on a number line, numbers get smaller. And if we go left of 0, we're dealing with negative numbers. So if we went down to negative 7, that's also 7 spaces away from 0. So this absolute value equation actually has two answers. It has x equals 7 as an answer, but also x equals negative 7, because both of those numbers are 7 spaces away from 0. It just depends on if you're moving to the right or to the left on your number line. So now looking at this equation, we've got the absolute value of x equals 15. So this means we want to think about numbers that are 15 spaces away from 0 on our number line. Well, if we think about going to the right where numbers are positive, 15 is 15 spaces away from 0. But if we think about going left on our number line where the numbers are negative, then negative 15 is also 15 spaces away from 0. So again, we have those two answers. We have 15 and we have negative 15. Now things do get a little trickier when you start putting extra operations in an absolute value equation. So here we have the absolute value of x minus 3 is equal to 8. So what this is really saying is that we're looking for some number that when we subtract 3 from it, it's 8 spaces away from 0. And that can be kind of tricky to think about. So here's what we can do. We can actually take this one absolute value equation and we can split it up into two separate equations that we can then go through and solve algebraically. So to get our first equation, what we're going to do is take a look at the equation that we're given with those absolute value bars in there. And the only thing that we want to do for our first equation is get rid of the absolute value bars. We're just going to pretend like they were never, ever there. So we get x minus 3 equals 8. But we do also need to get our second equation. So for our second equation, what we're going to do is we're going to drop the absolute value bars. So that just becomes x minus 3. But on the right-hand side, if we think about the last couple examples where we had 7 and negative 7, and then 15 and negative 15. Well, here this is equaling 8. So we've already got one equation that equals 8, but for our second equation, we're going to set it equal to negative 8. Okay, so we dropped the absolute value symbols, but then we changed the sign on the answer on the right-hand side. So we turned it from an 8 into a negative 8. Now to get our two separate answers, we're just going to go through and solve each one of these equations individually. So if we start with the red equation, x minus 3 equals 8, to get rid of that minus 3 that's attached to my x, I need to add 3 on both sides. So that's going to leave me with x equals 11. So that's our first answer. And if we go over to our other equation, x minus 3 equals negative 8, when I add that 3 over to the right-hand side, I get x equals negative 5. So thinking about what we said earlier, when we talk about this equation up at the top, this is saying that we have some unknown number. When we subtract 3 from it, it's 8 spaces away from 0. And if we think about what's happening, 11 minus 3 is 8, and 8 is 8 spaces away from 0. And here, if we were to plug in negative 5 minus 3 is negative 8, and negative 8 is also 8 spaces away from 0. So our two answers are x equals 11 and x equals negative 5. Looking at this next equation, we've got the absolute value of b minus 7 equals 9. So again, we're looking for some number that when we subtract 7 from it, it's 9 spaces away from 0. So I'm going to take this equation and I'm going to split it up into those two separate equations. So for the first one, we just drop the absolute value and pretend like they were never there. For the second one, we drop the absolute value, but change the sign on the answer. So we turn that 9 into a negative 9. Now going through and solving these, starting on the left with the red equation, b minus 7 equals 9, I'm going to add that 7 over to the right-hand side. That's going to cancel out. So we're going to get b equals 16. And then if we look at our other equation, again, we're going to have to add that 7 over to the right-hand side to get it to cancel out. So we should get b equals negative 2. So our two answers in this case are b equals 16 and b equals negative 2. Next example here, we've got a plus 6 equals 12. So again, we're looking for some number that when we add 6 to it, it's 12 spaces away from 0. So I'm going to write out my two separate equations. So a plus 6 equals 12. So we just write out the equation without the absolute value symbols in there. For our second equation, we get rid of the absolute value symbols, but we change the sign on the answer. So we turn the 12 into a negative 12. Solving this equation in red, to get rid of the plus 6, we're going to have to subtract 6 on each side to get that to cancel out. So we're going to get a equals 6 as our first answer. And in our second equation, this blue one, a plus 6 equals negative 12, if we subtract that 6 over to the right-hand side to get it to cancel out, we should get a equals negative 18. So the two answers are a equals 6 and a equals negative 18. Next equation, we've thrown one extra piece in there. I've now put a coefficient in front of the variable. So there's a number in front of that variable. So now we've got the absolute value of 2p minus 3 is equal to 7. So just like we've been doing, we're going to split this up into our two separate equations. So for the first equation, the only thing that we want to do is get rid of the absolute value symbols. We don't change anything else. But for our second one, we're going to get rid of the absolute value symbols, and I'm going to turn that positive 7 into a negative 7. Now, if we work on the left-hand side, this is a two-step equation, so we want to get rid of that minus 3 first. So we're going to add 3 on both sides, and that's going to leave me with 2p equals 10. I still need to get rid of that 2 that's attached to the p. 2p really means 2 times p. So to get rid of that times 2, we're going to have to divide both sides by 2. So that leaves me with a p-value of 5. Now if we take a look at our other equation in blue over here, 2p minus 3 equals negative 7. First thing I'm going to do is add that 3 over to the right-hand side so it cancels out. We're left with 2p equals negative 4. We still need to get rid of that 2 that's attached to the p, so we're going to divide by 2 again. So we're going to end up with p equals negative 2. So our two answers in this case are p equals 5 and p equals negative 2. That's going to be it for this video. Thanks for watching.